Hello, this is Calculus Explained, and welcome to this video on the definition of the derivative. Now, this also introduces our next unit on derivatives. So we know how to measure average change, average speed, average growth, average slope. But calculus asks a harder question. What's happening at a single instant in time? So let's look at an example. Say we have a position versus time graph. This is x, and this is t. And the function looks like this. We'll say that this is x squared. 1, 2, 3 for our times. Now, if we want to compute the average speed from time equals 1 to time equals 3, we first look at the points. This is 1, 1, and this is 3, 9. Now, to compute average speed, we know how to do this. F of b minus f of a over b minus a. This is just rise over run. So then we get 9 minus 1 over 3 minus 1 equals 8 over 2 equals 4. So that would be the slope, or the average velocity between time equals 1 to time equals 3. But what if we want to ask, what is happening at x equals 2? What is the exact slope right there? That is where calculus comes in. So derivatives exist because nature doesn't move in chunks. It moves continuously. So this is where calculus truly begins. Now let's use limits to figure out how to compute the derivative. Now let's say we have a function and it looks like this. This is x, and this is x plus h. That would be x plus h, and this would be x. Now to compute the slope from between x and x plus h, we would use our formula f of b minus f of a over b minus a, and you get f of x plus h minus f of x over x plus h minus x, which is f of x plus h minus f of x over h. But then we see that as this goes closer and closer to 0, this point moves closer and closer to our other point. So then we see, well, we could use a limit. So then we say the limit as h approaches 0 of f of x plus h minus f of x over h, that is going to be equal to the slope of the tangent line at x. So that is the definition of the derivative. Now we write the derivative as f prime of x. This prime indicates that there is a derivative. Now there are some different ways to show the derivative, such as dy dx. This is a common one for implicit differentiation, which we'll get to later. Another one is d dx of f of x. That's a common one. Sometimes we'll just see it without the parentheses. It'll just be written as d dx of f of x. So those are some different ways to show the derivative. Now let's practice. Let's say that we have f of x equals x squared. This is our example up here. And we want to find the derivative. So we say f prime of x equals f of x plus h, the limit as h approaches 0 of x plus h squared minus f of x minus x squared over h. And this is equal to the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. We cancel, and then we can factor out an h. So then we get the limit as h approaches 0 of 2x plus h. And then we just use direct substitution to get 2x. So that is the derivative of f of x. This means that at x equals 2, we can plug in 2 times 2, and we get 4. So that just so happens to be this slope right here, the average slope that we got earlier. This isn't always going to be the case, but in this scenario, it was. We could also do this for any point, such as x equals 1. Since f prime of x equals 2x, you plug in 1 to get 2. So that means the slope at 1, 1 is 2. At 3, 9, it would be 2 times 3 equals 6. That would be the slope of the tangent line at 3, 9. So that's how to compute the derivative using the formal definition. Now let's look at some practice problems. 1. Find the derivative using the definition of f of x equals x cubed. Number 2. Find the slope of the tangent line to f of x equals x squared plus 2x plus 2 at x equals 1. And number 3, interpret the derivative. What I mean by this is, if f of t is position, then what does f of t represent? F prime of t represent. So pause the video, try these on your own, and when you're ready, we'll go through them together. Welcome back. So for the first one, we use our definition. F prime of x equals the limit as h approaches 0. In this case, it'll be x plus h cubed minus x cubed over h. We expand this to get x cubed, the limit as h approaches 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed all over h. Cancel. And then we cancel out these. And then we get the limit as h approaches 0 of 3x squared plus 3xh plus h squared. Direct substitution cancels these out, and we get 3x squared. And that is the derivative. Now next, for number 2, find the slope of the tangent line to f of x equals x squared plus 2x plus 2 at x equals 1. Now again, we use our limit definition. F prime of x equals the limit as h approaches 0 of x plus h squared plus 2 times x plus h plus 2 minus x squared plus 2x plus 2 all over h. Now we expand this to get x squared plus 2xh plus h squared plus 2x plus 2h plus 2 minus x squared minus 2x minus 2 all over h. And it's the limit as h approaches 0. So now we can cancel like terms. These x squared cancel. Then we see this cancels here, and this 2 cancels with this 2. Then we can cancel out the h's. And from there, we get the limit as h approaches 0 of 2x plus h plus 2, and then direct substitution, cancel out that h, and we get 2x plus 2. Now, for the slope of the tangent line at x equals 1, we plug in 1, so then f prime of 1 equals 2 times 1 plus 2 equals 2 plus 2 equals 4. So 4 is the slope of that tangent line. Now lastly, interpret f prime of x. So if f of t is position, then what does f prime of t represent? Well, it would represent velocity. Recall that if you have a position versus time graph, the slope of that graph is always going to be equal to the velocity. And similarly, if you have a velocity versus time graph, the slope will be equal to the acceleration. So that concludes this video. Today, we defined the derivative using limits. This definition is powerful, but using it every time would be very slow, as you have seen. In the next video, we'll develop rules that let us compute derivatives instantly. I hope you enjoyed this video, and I will see you next time.